In this video, we'll be looking at the guidelines for finding dy dx with implicit differentiation, and then we'll do an example. Our first step is to differentiate both sides of the equation with respect to x. Then collect all terms containing dy dx on one side of the equation and put all the other terms on the other side. Factor out dy dx, and then solve for dy dx. The problem that we'll be working is to find dy dx given y cubed plus y squared minus 5y minus x squared is equal to a negative 4. Let me rewrite this. So our first term is y cubed. We're differentiating with respect to x. So this one needs to be 3y squared times dy dx. Basically, when you're differentiating with respect to x, if it's a y term, you go ahead and differentiate it, but you need to use the chain rule, so you multiply by dy dx. Our second term, the derivative is 2y times dy dx. Our third term, the derivative is negative 5 times dy dx. Now this term is already in x, so the derivative of negative x squared with respect to x is just negative 2x. And then the derivative of a constant is 0. Now we want all of our terms with dy dx on one side of the equation, and then we'll put this negative 2x on the other side by adding 2x to both sides. So we have 3y squared dy dx plus 2y dy dx minus 5 dy dx. And then when we move this term to the right side, it's a positive 2x. Our next step is to factor out dy dx. So dy dx pulled out in front leaves us with 3y squared plus 2y minus 5. And then on the right we still have our 2x. And then solve for dy dx, so we'll divide both sides by 3y squared plus 2y minus 5. These will cancel, and we end up with dy dx equals 2x over 3y squared plus 2y minus 5.